on that. It is not purely technology specific. In fact, a lot of the work that I've done on the cloud has been, rather than using any specific technology solution or any specific cloud platform, it's to try and figure out the best, the most cloudy way of doing something for myself. And what this session is, however, is a series of experiences. And that final learning outcome that I talked about is mainly to consider cloud architectural considerations. So that means the next time you all look at building for the cloud, you all will have hopefully, if not exactly a checklist, but a series of thoughts or shall we say key factors that you all can consider, or maybe some key learnings that you all can apply from this session. So let's move on to story number 1. This would be pretty much my first experience with the cloud. Some of the people who worked with me around about that time are also in this audience, so maybe they can remember the customer, who obviously I can't mention, but their domain was very similar to Stack Overflow. What they figured is, look, there's so many people out there, maybe if we can incentivize them to, help solve problems which other people bring in, well and good. Sadly for them, they're out of business today, but it's not my fault, so don't look at me, right? But the problem that they had was that they had custom algorithms which were targeting intensive database writes. And this had a high probability of affecting read operations, which if you think of Stack Overflow would be the majority scenario, right? So many people come, they want to see answers, right? And far less people spend time actually posting on it. So they were faced with this scenario, and they were trying to figure out what the right way of solving this problem was. Now, this was around about 2008 or 2009. It was a Scandinavian customer, and Stack Overflow was also birthed in 2008, for those of you who recall. And the thing was, cloud was very much in its infancy at the time, right? Even hosting platforms, the offerings that were out there back then were not as mature as today. And the problem that they faced with was that there were no design patterns, no cloud design patterns to seek recourse to, right? The solution lies in something that you all might have already heard of. How many of you all have heard of CQRS? All right, there's 1, 2, and I suppose 3, and I'm sure there's about 30 of you all who have already heard about it but don't want to raise your hands, so that's cool. This was a solution, right, that was used to overcome this problem. A quick diagram of it will show you where all of your writes, which would typically maybe use something like a CRUD model, goes into your persistence. It's replicated across to another database from where separate model can be used to pull back data for display, which is your query scenario, right? Just to go a little bit further on that point, the reason why I brought this out is you'll probably find scenarios where for varying reasons, even right now I'm on a project where there is an existing system where on a monthly basis payroll advices are sent out, right, via email. They are taken, crunched up, made into PDF documents, sent out via email and so on. And you will find situations where you wouldn't want to hit the million or so users who are trying to log in at the same time, right? If your user base, hopefully if your user base is so big. So this would be one technique that you should definitely have in your toolbox. And at a micro level, that's the learning that I took out of that very first experience that I was exposed to the cloud in. Story number 2 was far more recent. It was in the sales and inventory control domain. How many of you all really buy the story of RealTime? I mean, you all have all seen these Hollywood movies. Some of you all would have heard me talk about this as well, where a guy puts on a data glove in a movie like Paycheck or something like that, and he's just moving his hand around, and everything seems to be happening. However many records you got to crunch, it appears that the data is coming through in real time, the queries are being run in real time, and it looks like magic. Unfortunately, it's you and me that usually has to implement that code to make it happen, and it's nowhere as nice, right? So doing something in real time, especially when the customer says it, usually winds up being a fairly big problem from time to time. It's a good problem to have. Hey, everyone needs their customers, right? But when the problems themselves come in, as I will elaborate in a moment, you will see why real-time is not always easy or not always possible to provide. The scenario, it was a restaurant system, restaurant slash inventory, and the restaurants obviously at different sites. This was both locally and now it's abroad, where the waiters could place orders using handheld devices. There'd be a POS application written in .NET Windows Forms. But the requirement came from top management and customers that they wanted their inventory to be maintained centrally, right? And of course, that would be updated by web. And well, it would be in the cloud, and there'd be a web interface to updating your stock balances for receiving goods and issuing goods. The problem was they thought that it would be a great idea to have all of these restaurant POS terminals, the mobile devices and all of that working directly off the cloud database, right? How many of you would think that this would be a great idea? How many of you, on the other hand, would think that this would be a bad idea? Well, clearly you guys have no idea, right? I think that's, well, let me put it this way. Think of internet connectivity in Sri Lanka, right? For those of you all who have been abroad, you all would know that you get much better service abroad, all right? Latency. What if the connection breaks? What if there is a customer who is trying to place an order, right? And your data is being served off the cloud, right? And your internet connectivity goes down. All right, let me rephrase that question. What if you were the customer, you were placing an order and the data was supposed to be coming off the cloud, and the waiter comes and tells you, sir, our network connection went down and unfortunately we can't serve you the food. I know you're full right now and you had lunch, and look at it at this point, it probably doesn't seem like a big deal, but if you were hungry, obviously you wouldn't be exactly Mr. Happy at that time, right? Secondly, it raises all sorts of questions about, all right, that would be the worst case situation that I took, all right? Let's say, for example, that orders can't be served out. What if things become slow, right? There's so many problems. What if there are a whole heap of operations that have to happen on the client side, at the site, as well as on the cloud? How do you make sure that this entire transaction's integrity is maintained from beginning to end, right? So practically, this approach, as you can see, this scenario brings up a fair number of problems. And let me just tell you why the management actually wanted this to work off one database. Well, firstly, it seemed cool to them at the point, thinking that you'll be always able to see the most real-time, the most live data, right? Come to think of it, that was the only reason they had, I think, because when they thought about it, what they wanted to do was provide a reporting solution where, let's say, the owners of the restaurants would be able to see the reports at any given time, how sales have been for a day, right? And the solution that we came to was change the problem. It wasn't actually about any technical solution that we brought in here. It wasn't about a framework. It wasn't about some sort of technique or design pattern that we used. What we did was change the problem, right? You might wonder why I've actually brought this into what seems like a fairly technical kind of session, right? But I think those of you who have been at some of the meetups where I presented and all would realize that sometimes an architect's job isn't purely technical. Sometimes it means solving all of the problems that come up from the project management perspective, from the customers, trying to explain to them why something should be done, why something shouldn't be done, and why if you're going to do something, it can't be done exactly the way they want, right? And all the while not stepping on their toes, right? So how we change the problem? Well, I think I already mentioned the key constraint that the site operations cannot take downtime, right? But the solution we took was to synchronize the data, right? So what would happen is that periodically data in the cloud would be pulled down, right? And site operations would run on their own. Say connectivity went down, no problem, the site continues to run, right? And data is synchronized periodically. However, this solution is not without its problems as well, right? What if someone is updating something on the cloud, right? While someone is updating essentially the same items back at the site, right? When the data is merged at a later point, there's always a chance for some sort of concurrency conflict to have taken place. The data could be mismatched, right? The best option in such a situation would be to notify users and provide facilities for the users to resolve the errors. But if you look at this model, I think looking back in hindsight, the hardest part was to try and convince the customers and the management and explain to them as to why they couldn't actually get what they wanted. So I think it was about a 3 to 4 month battle where I had to tell them one way, then another. First the gentle approach, then perhaps a slightly harder approach, back to the gentle approach. Sometimes you got to let them try out the research for themselves and then see the problems, right? Tell them, but hey, do you want to cut yourselves off from market opportunities into a place which has only got dial-up connections? And they think for a moment and say, maybe not, right? Forget the fact that dial-up is kind of, disappearing. It doesn't matter. I mean, it's all market share from their perspective. So sometimes, if you are the architect, remember that all of these problems don't have to be solved from a technical perspective. Sometimes there are alternatives, part technical, part marketing, part managerial. And at the end of the day, I think within the domain that you're operating in, there are certain optimizations that you can always do. Fortunately, in the areas that we were working in, the times that goods were brought into inventory and all of that were not really key restaurant operating times. So you'd always have a good chance of syncing data, minimizing concurrency, that window you have for concurrency. There are so many optimizations that you will be able to find in your specific scenario, in your specific company, in your specific project. Scenario number 3, or story number 3, this comes from the vehicle management domain. How many of you are familiar with the concept of sharding and multi-tenancy? Right. Again, one. I see people who I know what sharding is. We've done it before together, so I'll just assume that that's probably about what 50% already know about what sharding is. Cool. So what happens when you've got when you're trying to build some sort of solution, essentially an ERP solution, where you've got multiple customers' data which has to be in the cloud, right? Typically, for those of us who grew up on developing web applications, what would we do? We just write the one web application, we'll put it out there on the cloud, well, on the web as it was back then. And then, you got this request that would come up to say, all right, support multiple customers, right? And often we've wound up by doing something like, well, let's take an example, throwing in a customer table or throwing in an organization table into the same schema, right? And typically that has worked. And of course, you've got to update your screens and all to support all of this as well. But it has worked. And there is a cloud concept called sharding, right? And while the solution that we found lay in sharding, right, it was not by any means the purest means of sharding or the purest approach that can be taken to sharding. What we did was we actually set ourselves up with a master database, right, which held all of the organizations, all of the customers, master information that we needed, along with a set of secondary connection strings to actually where their data would be stored. Separate databases, identical schema, right? And what we went ahead with was a model where, all right, the UIs could be parameterized either based on the domain that they were working off of, or in the same user interface that we give the users the option of switching between organizations if they had sufficient permissions and work across these different organizations in the same application. The key learning that I took from this, right, the main experience was that sharding is not that hard to implement as long as it belongs to this kind of domain. For those of you all who are looking at the Facebook model of, a billion posts, right, and you're trying to share that data across, a large storage repository of sorts, you all would be faced with far more complex issues in terms of, what's the sharding algorithm to be used, what if one shard fails, and so on. But in our situations, most of us don't wind up writing Facebook scale apps, do we? Most of us wind up writing inventory control, well, essentially ERP, right? Line of business applications, right? And why I've actually suggested this as a learning point that you all can take from these experiences or these problems that I've faced in the past is that applications that we develop typically are focused at only the customer's requirement initially. As you all take on more and more senior technical roles in your organizations and on the projects that you all are involved in, you all will probably have an opportunity of recommending components and solutions which might actually help build up the software to a much larger scale, right? To help grow your business and your customer's business, which inevitably happens to be good for you, right? And this is a fairly easy takeaway, right? To build essentially a master database or a master index which stores the master information for the customer or the organization or whatever criteria you are using to slice data, and have separate schemas or separate database instances for the different customers so that you can grow the business. You have a new customer joining up, spin up a new instance for them. This actually works very well with the cloud model because, all right, as your business grows, so does your resource consumption. But as your user base is growing, as your customer base is growing, you get to charge, you get to make money on this model. So what I would encourage you to do is not to lock yourself down, right, in terms of thinking purely with the old model of writing, just for the one customer, right? Think of the longer term, right? How much time do you think it would take possibly to write this functionality? How long would you all think it would take? Any thoughts from over here? Think about it. Separate database master. Wouldn't take that long to create. One table in there. Few columns for connection strings and so on. Right? Whatever repository pattern or whatever you're using to connect your actual data, parameterized by whatever connection string you pull out. 3 bullet points. 4th bullet point, you take it, you cache that information so that you don't have to go to the DB every time. 5th bullet point, you make it configurable so that you can switch it off, and if you only have to focus on one customer at a time, right? A week, 2, 3. Well, if you're taking 3 weeks for that, you're really pushing it, but surely 1 to 2 weeks plus maybe a nice little administration console to put in a new customer. I'm more than confident that pretty much everyone in this room should be able to do it inside 2 weeks for sure, right? So it's just a thought, but to elaborate on what I told you at the beginning, that I will not be going technology specific in this session, is to try and get your thinking from how the cloud operates, how you build for the cloud, right? Just try to get the whole cloud model into your mind. How do you support multiple customers? How do you grow that customer base? One question that was asked of me is, all right, you know what, these customers, they are not willing to pay as much, right? So we are not going to give them top level service. What do? We throw about 2 or 3 of them into the same database, right? So you get, you can build a marketing model around that. If you want your own dedicated instance, here's how much you have to pay for it. Or hey, if you don't want a dedicated instance, what can you do? You can go to a much smaller instance, a shared instance, right? And quality of service might drop, but then how much it drops is up to you, right? So it's easier to build this into solutions and adding later, and that's one of the main takeaway points that I'd like to bring up here as well. And I would recommend that you configure it to off initially, because at the beginning, you've got just one customer, you're just trying out your software, you really wouldn't want to, go the whole hog and, try to make it operate at full power, as it were. But the main focus is it gives you scope to grow your solution as time goes by. So the challenges that come across, that you'll come across if you go down this route, and this is one thing that you'd be best served warning your customers and any management decision makers, is that, all right, you've got an index database, you've got a separate database per customer, right? And someone wants reports that pulls data across all of these databases and shows it to you at one go, right? Cross-database queries aren't typically a very good idea, right? So one option that you might want to do is maybe have some sort of background process that pulls data back amalgamates it, crunches the numbers, and has reporting data available for those who want cross database reports, right? It will take a little bit more time to build, and I think I mentioned the word real time earlier, right? At that point, real time is out of the question. Why? You are running periodical report aggregation of data for reports, so real time is out of the question, right? So there are certain caveats, certain problems with each of these approaches, but I would bet you dollars to donuts that most management teams or most customers, if that's the scenario you're faced with, would prefer to have a solution that can grow, right? And they can bring on more of their customers on board, rather than certain, shall we say, short-term reporting limitations, right? So this would be a very, very big takeaway point for me, not so much from just raw sharding from a technical perspective. It's more in terms of approach as to how you build your software. I would say as much as possible, try to take that extra time, build it in initially, and the payback is in the long term. Missing credit. Now this is actually a bit more personal story, but it's related to a travel opportunity that I got for work, and I tried to purchase Skype out credit, right? I went to the buy credit page, bought some credit. They only offer $10 blocks at a time, right? It takes you back to a page where it shows you your balance. Went, bought some more, came back, and I didn't see a change. It still showed $10 or whatever it was. And I thought, silly me, I had gone and pressed the cancel button rather than buy. So what I thought is, well, I still do need another $10, right? So I clicked again and said, I want to buy $10 more. Imagine my surprise when I come back to that first page and I actually find that I've now got $20 additional of Skype out credit, right? And it would have been fine if Microsoft was giving it to me for free. But apparently when the bill came, actually, yeah, it was $20 and I had paid for it, right? So it would have been great, but actually it was a bit of a surprise, a nasty surprise, because we are typically used to what? Building transactional systems. We are used to making sure that what goes to DB is what we pull out, right? And the word with the cloud is that model is gradually, but very surely breaking down, right? Little by little. Now, Skype isn't actually the kind of company that you think about as typically cloud, right? And we talk about Facebook and all that, and maybe it's to some extent because Skype preceded the cloud and the big cloud boom, right? But they're out there, right? And their operations are on that scale, right? So that's why I thought it would actually make sense in this session, because while it isn't actually to do specifically with the cloud, this can very well happen with any application that we write. So it's possibly worthwhile thinking through and possibly worthwhile guarding against when we build our applications, right? So what were the probable causes? The CQRS that I mentioned earlier, right? We are writing to one database, we are pulling out from another, right? So let's say the updates, the purchase operations, the transactions have been written to one database, but the balances are being pulled out of another, right? Great chance for a slight mismatch. I mean, we are talking seconds or milliseconds here, right? And if we were writing an application that was, let's say, for example, Stack Overflow, questions and answers, right? Or Facebook, wall posts, right? Not exactly business critical / mission critical, right? It's all fun. It's not something that someone's going to typically make a business decision off of, right? If that were the case, maybe it wouldn't be a problem. But when you're writing ERPs, you're writing actual business applications, right? It could pose a problem. Why I brought it up very specifically and why I took this example is Skype out end of the day is money, right? It's money spent, right? And I might have expected to see this anywhere else in terms of Facebook or again Stack Overflow, but where I didn't expect to see it happening was with rupees and cents or dollars, right? So the mindset is definitely changing, right? But this is really not the kind of thing that you'd want to take a gamble on for yourself, right? It's not the kind of decision that you'll say, oh yeah, you know what, I'm going to use CQRS and you know, who cares whose dollars it is, because definitely when the bugs start showing up in production, it's probably not going to be a good thing, right? So this is where you'd actually want to talk with your customers, talk to your management team, your project management team, figure out what the best way forward is, whether they're okay with it, and if they're okay with it, I guess it's a viable option. Message queuing is another scenario where this can happen. You've got decoupled systems which are operating on their own by and large, except that any connectivity is through something like an enterprise service bus, a message queue, whatever middleware of choice that you've got. So while data makes its way from point A to point B, there's always chance of lags and inconsistencies showing up. Another spot where scenarios like this happen is with caching, though of course in this specific example it's quite unlikely because this is transactional data we are talking about. It's quite possible that data was cached and the read request was served out of a cache. It's quite possible in some scenarios it might be caching that's showing you that's showing up as data inconsistencies, though like I said, unlikely in this scenario. Right, so as I said, a changing world. We are in a changing world where we are used to transactions with acid properties, right? Those properties which I'm sure all of you would have heard at campus lectures and being questioned on at interviews. But we are moving towards a model that is known as eventual consistency, right? Where if a subsequent change doesn't happen, after a while for sure you're going to get the most up-to-date data eventually. And like I said, Facebook, wall posts, great. Stack Overflow, question and answers, great. But if you're dealing with money, if you're dealing with mission critical operations, depending on your context, your project, your company,